Geostellar provides an integrated Earth model for renewable energy development. Unlike solar potential measurement services that derive data from satellite and field sensors alone, Geostellar applies big data geomatics to compute the precise amount of sunlight that falls each day of the year on each square meter of the globe. Every morning, the sun rises and sets at a slightly different time, based on the latitude of the site and the position of the Earth in its orbit around the sun. Over the course of the day, the amount of solar irradiance that reaches each acre of ground depends on cloud cover, humidity, topography, tree cover, buildings, slope, and aspect. Geostellar accounts for all of these factors programmatically, ranking sites for solar power potential across continents, nations, states, and counties. This is a 10-meter resolution solar potential map of the state of New Jersey. The colors represent the amount of solar irradiance in kilowatts per meter squared that reach each spot of Earth each day, averaged over the course of a year. At the low end, areas where the pixels are black receive less than 1.8 kilowatts per meter squared per day over the course of a year. The gray areas, from darkest to lightest, receive between 1.8 and 3.2 kilowatts per meter squared. At 3.2 kilowatts per meter squared, the deep brown shading begins. The color lightens progressively through tan at increments of 1/10 of a kilowatt per meter squared. Above 3.8 kilowatts per meter squared, the color map shifts to yellow, reaching its lightest shade in this particular state at 4.5 kilowatts per meter squared. You can see at a glance that the solar power potential in the southern part of the state, where the land is gently sloped towards the sun, is greater than the solar potential in the hillier terrain of the north and central regions. With the click of the mouse, you can exclude the areas that cannot be developed for utility-grade solar. The areas that are pure white include wetlands, sensitive environmental areas, agricultural easements, and urban areas with parcel sizes below 9 acres. Through the simple interface, we can see pine lands shaded in blue. These areas are not necessarily excluded, as they may be opened for development in the near future. Then, in shades of pink and orange, we can see federal government lands, such as military bases, national parks, national wildlife refuges, and protected areas. Geostellar aggregates and incorporates every type of information that might impact your project development plans. You can view federal, state and municipal properties, water features, historic properties, cultural sites, preservation, zoning and environmental protection, geology, microclimates, land ownership, infrastructure, political boundaries, agriculture, resources, and topography. To look at a promising area more closely, you can create a box and zoom in. When we enlarge a region, the tax parcel boundaries become apparent. Let's look for development opportunities close to transmission lines. By selecting the substation icon, we can see that this is the New Vienna substation. It is connected to a 69 kilovolts transmission line. These nearby tax parcels have high solar potential compared with the surrounding area. Let's take a look at land ownership. These two lots, owned by Reagan Inc., are 109.25 and 27.5 acres, for a total of 136.75 acres. The adjacent lots, owned by Connie Wilson, are 25 and 70 acres, for a total of 95 acres. The next lot over to the northwest, owned by the Mary Ann Georges Trust, adds 87 acres to the possible leasehold. Contact information for the owners is included in the tax parcel layer. We can see by selecting a few exclusions that these parcels are outside the 100 and 500-year floodplains and are not in close proximity to cemeteries, cultural sites, or state parks. Let's look more closely at the area of interest. we can see that there are some alternative sites a short distance away, owned by Carolyn and Lewis Max Sharp and Norma Lee Woodruff. The solar potential for our area of interest, modeled at 10 meters resolution, ranges from 3.7 kilowatts per meter squared per day, averaged over a year, in darker shades, to 3.5 kilowatts per meter squared per day in lighter tones. Selecting a few spots, we can see that this area, which receives over 3.66 kilowatts per meter squared on an average day, is 1.14 kilometers from the substation. Coming in even closer, we can explore the solar potential within each 10 square meter pixel and compute the solar power generation of the site under various scenarios. We can even explore the digital elevation map, or DEM, to find out what geological features are occluding the sun and determine whether it would be cost-effective to grade the site and produce more power per acre. Finally, let's take a look at a county with solar potential modeled at 1 meter resolution using a digital surface map, or DSM. Unlike the 10 meter resolution DEM that accounts only for meteorological, atmospheric, and geological features, the 1 meter resolution DSM also counts for shadows from trees, buildings, bridges, and other objects on the land surface. For utility-grade solar, this looks like a promising part of the country. Zooming in further, we can see the dramatic difference small variations in terrain can have on solar potential when aggregated over the course of a year. On this 69-hectare parcel, the solar potential varies from point to point by 5, 10, 15, or 20%. By comparing the DSM results with the DEM, we can determine which occlusions are caused by geology and which by vegetation, whether the site can be cost-effectively developed, and the precise amount of power that can be generated on each square meter. With Geostellar's utility-grade solar energy prospecting and development system, you'll have complete geomatic intelligence on solar potential, ownership, environment, and infrastructure for every potential site in your area of interest before you set foot on the terrain. Accomplish more, produce more with Geostellar, the power of place.